In this video, we're going to demonstrate the power of the ProtoTRAK RMX solid model programming. So first, let's bring in a solid model, and it's going to be a parasolid with an X_T extension. Let's go to the begin. And now this part here is misaligned to how I want to machine the part. So I'm going to bring up the face. I mean, we can pick any face we want. This is the face that I want to be perpendicular. So I'll select this. A is perpendicular to the Z axis. And now if I rotate that and say show me the face view, yes, that's the face I want to work on, but it's misaligned to the axes. So I'm just going to select a flat surface, and I'm going to say here, align that to the x-axis, which it did. And now I'm going to rotate it into a position that I want to hold it in my work holding device. And I'm all done with this. So if I just cock this now and say give me the face view, it's in the proper orientation to how I want to machine the part. So now I can continue on. Now it's going to ask me to describe where my origin is. So I'm going to click the top surface and say set Z absolute 0. We have three choices to make here: center, endpoint, or intersection. Center would be, see this red dot, this is where it thinks the origin is right now. I pick center of this, that's the origin. I pick B, which is the endpoint, click an endpoint, that's the origin. I want A, intersection of this and this, that's my origin. You see these numbers down here? If I drag out to the far corner and you look at those numbers, you'll see they're about 12 by 6. So I know a 12 by 6 block will allow me to machine this part. Move on. And now I can also do some inquiring of geometry. If I click that hole, I can see that's a 310. And the counter on that is ½ inch diameter countersink. These holes over here, they're 440s. And the counter bore on those things are 700. This radius in here is a ½ inch, so this little rad up here looks like my smallest one on the inside is the 3/8. So I get an idea of what size tools I need to use, and well, I get an exact idea for my drills of what diameter I need to use. So there's a whole lot of built-in CAD functionality in here. Some you're going to use, some you want. Maybe you want to add a lead-in line here. So, and again, these numbers come into play because you can see how far out you have to drag this to be clear of your workpiece or your block size. So I'm going an inch back. You can also do things like add a line between endpoints, between that endpoint and that endpoint. I'm just going to undo that. Between that endpoint and that endpoint. And let's say I need to break this line right here. For some reason I need this line. I can just say here, break this line here. And now I could say hide this line. And now I only have that line left. I don't really need that, so I'm going to hide it as well. But you can create some basic things to maybe help you get yourself on center. There's all kinds of little necessary tools in here that you would use on a regular basis. And of course you always have your fit draw. So let's come in here and let's poke some holes. Actually, let's do this pocket first. Do I want to chain? No, I don't need to chain the pocket. So I'll come up here to event and just put in my centers and just put in the radius, and by default I have my default for pocket set to counterclockwise, so I punch that right in for me. That would be the top of the part, 30 thousandths top of the part. And I should show you something here in defaults. If we come down to the bottom here, there's parasolid defaults that you're pretty much going to set one time and then just forget about them because they're your preferences. That's what defaults is all about, is the way that you like to machine. I like my default rapid to be 30 thousandths. I want if I'm milling through the part, I want it to take the thickness and add an additional 30 thou to it. Same if I'm drilling through, I want it to take the thickness, the drill point, and an additional 30 thou. Now these numbers you can put in, change them to however whatever you like to use. It's all about you. So my Z end, I don't know how thick this is, so I'm going to go over to the solid view, flip it over, click the back side, and I can see it's 1 inch thick. And we're milling through, so I want to say with the offset. And you notice it put that 30 thousandths that I like to have for an offset. I put that additional 30 thou in there. Exit the solid. Number of passes, I'll do this say in 3 passes with a 15 thousandths finish cut. I want to run at 4,000 RPM to rough finish. I'm going to helical in at 30 inches. I'm going to cut it at 50 inches in roughing, 30 in finishing. I'm going to use tool 1 to rough and the same tool to finish. So now I want to cut this profile. Don't change this profile. And my Z rapid would be the top of the part again. The depth of that would be here. And this is 388 in the minus. But I want to go 388 deep. I don't want to go any deeper, so I'm going to say no offset. And it put that exact number in for me. You can see you really don't need a print here because you're going to pull the dimensions right off of the solid model, right? I'm going to do that in a singular pass, and I'm going to keep all this the same and the same tool. So it's nice that I remembered that. Now I want to poke these through holes. And if you can't remember what size they were, just go back, inquire the geometry, click on the hole, and you can see the 3 10s. So now we'll select drill. And suppose you picked the wrong one. Whoops, I didn't mean to pick that one. Just come over here, hit undo, and then go back and pick the one you want. Go into event and fill in what's missing. Now my Z rapid is going to be not for the top of the block. I'm missing Z rapid from what's already cut away. So I'll come down here and say that surface, which is 388, but I want to apply my offset to that. So I made it 358. I put it 30 thousandths above, which is my rapid clearance plane. And the Z end of these are going through. So we'll click on the underside surface. And if we turn off this, we can see that's 1 inch thick. And I'm going to use the drill tip. There's my drill tip. And I want the also, so this is 10931. I also want that extra 30 thousandths added to it. And you can see it's done all that math for me, which really simplifies it for a guy like me. I'm going to cut this at 1800 RPM, 12 inches feet, and use tool number 2. But I like to jump back and forth. It makes it real easy to pick stuff. It makes it easy for me to do it that way. You can do it any way you like. Now we need to do these countersunk holes, so I'm going to grab those countersunk holes one at a time here. And my Z rapid is going to be this with the offset. And my Z end, I'm just going to zoom in on that surface right there. And you see it's put the depth in for me. And I'm going to say with no offset. And punch that number right in. That really makes it easy to calculate your countersunk holes and hold an accurate, I believe it was a 1/2 inch diameter here at the top. I'll do that in 2 pecks. That's fine. Number 3, tool number 3. Now, I'm not going to program this entire part for you. I'm just going to show you the profiling bit and chain in that. If I say profile, if I say chain no. Now I may have this section of the part right here held in a vise. I only want to work on this section out here, so I'd say chain no, and I just pick the entities that I want to work on. But in this case, I'm going to be tied down from the inside, and I want to machine the entire periphery of the part. So I'd say chain yes. Now the order in which you pick the entities, the first one you pick is your start point, the second is your direction. So if I wanted to do this as a pocket, I might pick this one, and it would go counterclockwise and allow me to climb cut the pocket. In this case, I'm doing a profile, so start here and go that way. You control the direction of cut, the start point and direction of cut. You can control everything with the ProtoTRAK. We'll go into event and we'll fill in what's missing at the top of the part. I already know it's 1 inch thick, so I don't have to go and pull that dimension off of the solid model anymore. Yeah, I'll go 4,000. That's fine. That's fine. That's fine. And I'll use tool number 4 to rough and finish. Now here you can jump into program mode. You can go into your tool table and set this up. If we look at our part here, so we did this pocket, then we did that counter bore, we did these 3 through holes, that's number 2. So we can go to our tool table here and we can say, let's see, let's use a 1/2 inch tool for that. This is tool number 1. Tool number 2 is a drill. That was a 310 drill. That's number 2. Tool number 3 is a countersink, so I'll use a 1/2 inch around that. And tool number 4 is a 3/8 end mill. So I've got my tools all set up, and I can verify that this is going to work, and it will work with the tools that I've given it.